In this section, we're solving optimization problems. And optimization problems are finding an applied max or min. So that means we're going through the absolute max and min part like we did in the earlier part of this chapter, except for now we have a scenario behind it. So we want to find the maximum area or the minimum surface area or the maximum amount of square printed area. So we've got a lot of areas in there, and we have some other quantities as well. But basically we're looking for absolute maxes and absolute mins of a scenario. Here are your guidelines. I'm going to go by those guidelines as we work these problems, so you might want to have that one handy. Okay, so a farmer, this is number 1, a farmer has 2,400 feet of fencing and wants to fence off a field. I included rectangular there because you needed to know the shape. Unfortunately, I left that out when I typed it. So we have a rectangular field that borders a straight river. So step 1 tells us that we need to draw the picture. Okay, so here's our river, and we're going to have a rectangular pasture. It's going to look something like this. Okay, it tells you that fencing is needed along every side except the river. So you're going to have fencing here along these red marks. Here's fencing, and here's fencing. So you're going to have fencing along all the red pieces. So we have assigned, we haven't assigned variables yet, but we have drawn the pictures. Step 2 says, write max or min and the quantity to be optimized. So if you read through there, it says, what are the dimensions of the field with largest area? So we're going to be looking for max area, largest area. Now keep in mind this is a rectangle. So the area of a rectangle is length times width. That is something that I expect you to know right now. So let's go back to our figure. We know we're going to be having length and width. I'm going to call the longer side length, and this side over here is width. Well, since it's a rectangle, that means the side over here is also the width. So that's my picture. Step 3 says write an equation for the area, which we've done. Step 4 says write this equation as a function of only one variable using other facts. Okay, so the only fact that we haven't used is that there are 2,400 feet of fencing. Okay, so if you look along the red region, you have W amount of fencing, and you have L amount of fencing, and then you have another side of W amount of fencing, and you have 2,400 feet of fencing. So that would be 2W plus L equals 2,400. Now those are your other facts. So what we need to do with that other fact is we need to solve it for one variable. The easiest one to solve for is the L. So L would equal 2,400 minus 2W. So you'll say, well, what are you going to do with that? Well, you're going to take that 2,400 minus 2W and plug it into the other equation. A equals L times W. L is 2,400 minus 2W. So multiplying that out, we would get 2,400 W minus 2W squared. Now then, our function is in terms of one variable, and that's what we want. Number 5 says optimize the function over its domain. That means find the absolute max or absolute min. So the way that we find the absolute max or absolute min is we take the derivative. So the derivative of this function would be 2,400 minus 4W. 2,400 minus 4W. So we're going to set 2,400 minus 4W equal to 0 and solve it out. Move the 4W over, 2,400 would equal 4W. Divide both sides by 4, and 600 would equal W. Now, I don't know that that's my answer or not. I need to check it. So, let's see, what are we checking? What you have to see, remember it's an absolute max or an absolute min, you have to see if there are endpoints. So let's talk about the endpoints for a second. Let's talk about the constraints that are on W. Well, I know that W has to be positive because we're talking about a length of fencing or a distance of fencing, so W has to be positive. I also know that L has to be positive. So if my length has to be positive, that means 2400 minus 2W has to also be positive. So, solving that one out, 2400 minus 2W would be greater than or equal to 0. Let me scoot that over a little bit. So negative 2W would be greater than or equal to negative 2400. Divide both sides by negative 2, and when you do that, you have to flip your sign. So W is less than or equal to 1200. Now you'll say, well, what did you do that for? Because remember when you do an absolute max or an absolute min back from earlier in this chapter, you have to check the endpoints of the domain. Now the way that you check the domain of this one, you knew that the width had to be positive and you also knew that the length had to be positive. So when you solved out the length, it actually gave you a restriction on W. So when you get ready to maximize this particular function over here, you're going to maximize it over the quantities from 0 to 1200. Okay, that's your interval that you're maximizing over. So what you have to do is you have to see which one of these gives you the max area. Okay? So let's go to a different page. Area equals, let me take this with me. Area equals 2400W minus 2W squared. Okay, I have three values that I need to plug in. I need to plug in W being 0, W being 1200, and W being 600. And we're going to see which one of these gives us our maximum area. Okay, if you plug in 0, you get that area equals 2400 times 0 minus 2 times 0 squared. So you get that your area is 0. That doesn't work. So then we can plug in 1200. Area equals 2400 times 1200 minus 2 times 1200 squared. Okay, so let's plug that into our calculators and see what we get. 2400 times 1200 is 288,123,4. Okay, so then we have 1200 squared times 2 would be 288,123,4, which would be 2,888,000. When you subtract that out, you get 0 for that one as well. So then you plug in your last one, 600. And area equals 2400 times 600 minus 2 times 600 squared. And so we get 720,000. Okay, so we had three different area values. We had area being 0, area being 0, and area being 720,000. Of course, the maximum one is the 720,000 one. So let's go back and make sure we answer the question asked. The last question says, what is the largest area? The largest area is 720,000. The other question says, what are the dimensions of the field with largest area? Okay, so let's look back at this slide. 0 gave me a 0 area, so that one's bad. 1200 gave me a 0 area, so that one's bad. So this 600 is the width that gave me the largest area. So I know my part of my dimensions would be 600. Okay? So what we have to go back and find is the length. Well, we can look back over here to find the length. The length equals 2400 minus 2w. Well, remember w here is 600. So 2400 minus 1200 would be 1200. So your length is 1200. So your dimensions are 1200 by 600 and your largest area is 720,000. Okay, trying to make this a little bit easier for you, usually, not all the time, but usually this answer that you get here for W when you solve out the derivative being set to 0, usually that's your answer. I have to show you all possible answers because that's my job, but usually this answer that you get here is what your answer will be for the problem. Okay, so that's your first one.